Welcome all. I am hereby to present my topic Solar Hybrid Thermal Power Plant, a future approach for energy sector. Objectives: a solar thermal power plant has been integrated into a conventional coal-based thermal power plant methodology to bring about hybridization in conventional thermal power plants. Introduction. Energy is a fundamental necessity for any nation in the industrial sector for production, modernization, and economic growth. Energy production and consumption patterns in manufacturing industries are incredibly unsustainable as greenhouse gas emissions are increasing rapidly. The amount of coal consumption in the thermal power plant for the same power output by partially substituting coal energy by concentrated solar energy. Figure of solar hybrid thermal power plants. Solar hybrid thermal power plant involves the simultaneous usage of concentrated solar power as well as coal energy for the purpose of steam production. The steam is used to run the turbine for the production of electricity. Since the process involves the simultaneous usage of concentrated solar power as well as coal energy. Proposed system of solar hybrid thermal power plant. The concept of solar power energy conservation and collection is based on a field of heliostats that reflect the incident sunshine to a receiver at the top of a centrally located tower. Solar energy to be collected in the entire field is transmitted optically to a small central collection region. Typically, 80 to 95% of the reflected energy is absorbed in the working field, which is pumped with the tower and into the receiver. The heated steam filters down the tower and into the receiver. Tabular representation of materials and their reflectivity is shown. Heliostat along with field type reflector is shown in the figure. Geometry performance of heliostat. Heliostat geometry is the single most important factor which determines whether the incident solar radiation can reach the receiver or not. It is known as fact angle of incidence. It is always equal to the angle of reflection as per the laws of reflection. Schematic representation of geometric performance of heliostat is shown. Parabolic through reflector. The parabolic through reflector is based on the CST line focusing technology which emerged in 1980s due to oil crisis. Parabolic through collectors focus the sun rays on the channels of pipes passing through their focus, thereby gradually heating up the working fluid present inside the pipe channels, which increases the heat transfer efficiency in general. Due to gradual heating, we need small size heliostats for the purpose. Schematic representation of parabolic through conductor is shown. Receiver tower and boiler. The receiver system has a boiler which is mounted on the top of the tower, which the reflected sun beam from the heliostat converts at the receiver. The working fluid gets heated to supercritical temperature. The steam then goes to the steam system which eventually sends the steam to turbine for expansion. It contains receiver pipe which contains oil which absorbs the heat incident on it to form the concentrated solar power. Receiver tower and boiler is shown. Shadowing. Shadowing occurs at its low sun angle when a heliostat casts its shadow on a heliostat located behind it. Therefore, not all the incident solar flux is reaching the reflector. Blocking. Blocking occurs when a heliostat in front of another heliostat blocks the reflected flux on its way to the receiver. This happens especially at the low sun angle, but it can also happen at other times of the day if there is no adequate spacing between the heliostats. Working principle. There are two LDR sensors mounted on the two diametrically opposite points of the reflector. Since there is a movement of sun, the light intensity of one sensor gradually increases and decreases on the other sensor. This leads to LDR becoming a conductor whereas the other an insulator. The conductor LDR gives output as 1 whereas the insulator LDR gives output as 0. Thus there is a difference in the output from both the LDR and LDR is connected to a microcontroller and so the output from each LDR is fed to the microcontroller which directs the motor drive to rotate the gear motor in a specific direction. Hardware used. The automatic solar tracker system constitutes following hardware: LDR sensors, Arduino Nano, motor driving, and VDC source. Conclusion. The threat of shortfalls in domestic coal production is constraining the development of coal power plants in a number of countries. Coal-based thermal plants in the base load operation consume tremendous amounts of highly specific operations consume hydro coal and make tight coal supply situations for assembled in the future if consumption remains high. If coal power plants can increase the flexibility of their operation while increasingly acting as a backup for renewable generation, coal consumption can be reduced. A primary option in this regard is to operate power plants more flexible. This is my references and thank you everyone.